Welcome to this explainer. If you're gearing up for your CIS 692 Capstone project, just take a deep breath because you are in exactly the right place. Today, we're going to absolutely demystify this entire course, create a crystal clear vision for what you're about to build, and really give you the ultimate big picture. We're going to break down exactly what this project is, step by step and week by week, so you can hit the ground running with absolute confidence. Here is our agenda mapping out your entire journey. We'll be hitting Section 1, Welcome to your Capstone, Section 2, Platform Architecture and Scope, Section 3, Professional Engineering Cycle, Section 4, the 11-week roadmap, and Section 5, your Week 1 action plan. Section 1, Welcome to your Capstone, the professional simulation. To succeed here, you need a complete mindset shift right from day one. The guiding principle for this course is simply this. You are a software engineer in a banking technology organization. This is a professional simulation. You are the engineer in the driver's seat, and your instructor is actually acting as your product owner and engineering manager. So you aren't just writing code to get a passing grade, you're fulfilling actual business requirements, you're making critical engineering decisions, and you're proving your work just like you would in any top-tier tech firm. Think about some of your previous courses. Usually, you have a collection of totally unrelated programming assignments, right? Like you do a lab on Tuesday and then a completely different homework assignment on Thursday. Well, not here. Instead, you're building one continuous master's level product over 11 weeks. Every single week adds a highly controlled increment to the exact same software solution. You plan it, you build it, you test it, document it, secure it, and eventually, you're going to defend it. The absolute most crucial point here is that you must manage your scope anxiety. A lot of engineers want to build the biggest, most sprawling application possible, and honestly, that usually ends with them crying on a Sunday night. A massive, incomplete, buggy system is not the goal. The true objective, and frankly, the stronger Capstone, is a highly focused system that meets all the required acceptance standards, passes all its tests, protects sensitive actions, and can be clearly explained. Quality and professional execution absolutely trump quantity here, every time. Section 2, Platform Architecture and Scope. What you are building. We're talking about an enterprise online banking microservices platform, and we actually give you the overarching design right away so you can focus on pure engineering execution instead of getting bogged down debating the tech stack. It's fascinating how cleanly this is laid out. The banking client communicates through an API gateway which perfectly handles routing and authentication via Spring Security. Below that layer, the business responsibilities are cleanly sliced into distinct microservices. They communicate synchronously via REST when they need to, and asynchronously through a Kafka domain event stream for things that don't need immediate coordination. And down at the data layer, it's a wonderfully robust, containerized system featuring Postgres for logical data ownership, Apache Kafka for events, and Elasticsearch for searchable projections. To break that massive system down just a bit further, let's look at the explicit boundaries of those microservices. A key rule here is that each service completely owns its data. The customer service handles all profiles and validation. The account and ledger service is the absolute authority on balances and immutable entries. Payment and transfer tackles the complex workflow of actually moving money. Search and audit provides our transaction evidence via Elasticsearch. And finally, the banking agent uses Spring AI to orchestrate restricted tools and request human approval for sensitive actions, because as we know, we never let the AI move money autonomously. This strict separation of concerns is exactly what makes a microservices architecture actually work in the real world. Section 3, Professional Engineering Cycle, How You Will Work. What's really interesting here is that the process of how you build this platform is just as important as the code itself. Professional evidence is a required part of your final product. You aren't graded just on whether an endpoint magically works on your local machine. You literally have to prove how the work moved from a requirement to a planned task, to reviewed code, to a tested behavior, and finally to acceptance. Every single requirement flows from Sodalic into Jira for your task management, over to GitHub for branching and pull requests, through a quality check with automated tests, and finally to acceptance via a demo and instructor review. Your weekly rhythm is going to become a well-oiled machine if you just follow these exact professional engineering steps. Step 1, review your assigned requirements and acceptance criteria. Step 2, create a Git branch linked directly to your Jira item. Step 3, implement the smallest complete vertical slice of functionality and write the automated tests for it. Step 4, open a pull request, review the diff, and make sure your CI checks pass. Step 5, demonstrate the milestone and attach your acceptance evidence. You just rinse and repeat that week after week. And remember, you cannot consider a task finished until it rigorously satisfies the definition of done. The acceptance criteria must be met using synthetic data, never real financial or personal data, obviously. Jira has to be fully updated. The code must be merged via a pull request with passing CI tests. And I absolutely cannot stress this enough. There can be zero private keys, passwords, or secrets committed to your repository. Unless, of course, you want to accidentally fund a crypto hacker's early retirement. If you meet all these strict standards, your task is truly done. Section 4, the 11-week roadmap, your path to release. The course is beautifully segmented into 4 macro phases: plan, build, integrate, and release. You systematically build up the complexity. We don't start by writing AI agents on day 1. We start with the foundation. We build the core banking tools. Then we integrate the advanced event pipelines and search, and we finish it all off by hardening the system for a highly defensible release. Breaking that timeline down further, weeks 1 through 3 are your plan phase, focusing entirely on onboarding, requirements, and architecture contracts. Weeks 4 through 6 are the build phase, where you construct the customer, ledger, and transfer microservices. Weeks 7 through 9 are the integrate phase, and that's where things get really fun. You implement Kafka event pipelines, Elasticsearch, and the Spring AI support agent. Finally, weeks 10 and 11 are your release phase for quality assurance, live demos, and your technical defense. It is absolutely vital that you follow this intentional sequence week by week. Resist the temptation to build future features early. Stay 100% focused on conquering the current week's milestone. Section 5, Week 1 Action Plan, your immediate orders. Okay, first, take a deep breath. You are not expected to implement banking features, Kafka pipelines, or AI agents this week. Your focus right now is entirely on establishing your foundation, configuring your environments, and proving you can navigate the professional workflow we just went over. Your assignment is to conquer this Week 1 checklist. First, absorb the core documents, the syllabus, the Capstone guide, and the AI policy. Then, knock out your technical readiness audit and get connected to Jira and GitHub. Once your local tools like Java, Maven, and Docker are configured, you get to clone the starter repo and run it to verify all those health checks pass. Finally, prove you can use the workflow by submitting a setup pull request. So I'll leave you with this pivotal question. Are your environments fully configured and completely ready for week 2? Once you prove your baseline runs smoothly, you step right into the real work. By the end of these 11 weeks, you won't just have a grade. You'll have built a massive enterprise-grade system from scratch. After engineering an architecture this complex, will you ever look at your own banking app the same way again? Good luck, and go get that environment set up.